We are Group 7 and our project is VidSynth. We've all been there. You find a YouTube video that you need to watch, maybe a coding tutorial or a product review, but it is way too long. You simply don't have time for that, or maybe you want to know what the audience really thinks, but you have to scroll through thousands of comments just to find the truth. This is why we built VidSynth. It is a smart tool that lives right in your browser. It uses a powerful cloud pipeline to summarize video content and analyze viewer sentiment for you. Let me show you how it works live. First, let me open the YouTube video that I want summary for and also the extension. Let me talk about security. We use a fully secure backend service. When I open VidSynth, I must log in. Let me enter my email ID and click send verification code. This hits our authentication service on Google Cloud, which triggers a dedicated SMTP relay to send a one-time password to the email that I've provided. So let me check my inbox. Here it is. I'll paste this code and click verify. This step is crucial because it allows us to track every single user who uses VidSynth. Now I'm logged in and ready to analyze this video. Before I click start, let me take you to the admin dashboard. This is the dashboard that we use to track our users. So we have a total of 5 users and the total summaries that are being generated are 16. So let me come back to this page once I trigger the pipeline. So this is our YouTube video and this is our extension. So I'm going to click on start analysis. But before that, I want to show you what is happening under the hood. Let me open the developer tools. So now I'm clicking on start analysis. So watch this. The moment I click start, you see this request sent to our gateway to summarize the video ID that I've given. We're not doing the heavy lifting here in the browser. We are sending a trigger to our cloud pipeline to say like, hey, start processing this video ID for this user. So the extension goes into a connecting state while it waits for the cloud to confirm the job has started. You can see the progress here. It refreshes every now and then to make sure it has the right output to be displayed in the front end. So now when I go back to the dashboard, you see the increase in the total summaries. Now when I click on refresh, it refreshes the front end to see if it has the output to be displayed in the extension. We now have the video summary and the viewer sentiment for this particular video. We save every result in our database. This means if I want to see the summary for a video I watched yesterday, I don't have to pay for the AI processing again. I can just click it from my history and it loads instantly. Let me show it for you. I click on history and I select any video, and now I have the corresponding video summary and the viewer sentiment for that particular video. And if I want to generate a new analysis, I'll just click on new, so that when I click on start analysis, it starts the same pipeline again for that particular video. So till now, we have securely logged in, triggered a complex job and tracked it live on our dashboard. But what exactly happens inside that cloud pipeline after the gateway gets the request? So I will hand it over to my teammate to explain the backend of our project.
Hi everyone, for this portion of the demo, I will show the backend setup from a completely fresh environment with no existing installs. This setup involves one Cloud Composer, 7 Cloud runs, 6 of which are DAG steps for the Cloud Composer, 2 main buckets, one to store the Llama model weights, and another bucket acts as a CRUD database to interact with the front end. So first I'll just show that again, everything is currently empty, no cloud run, nothing in artifact registry, no cloud composer. So back to the setup, it will involve 3 scripts. So first, for prerequisites, there are very few. Obviously, you need to have a GCP account. You will need to set up billing yourself, and you'll need to set up some APIs, Hugging Face, YouTube, and I've ran these commands already, so you need to run those. Clone our repo. Change to the location of the scripts. Ensure that they are now executable. And we'll run the first script. So again, this script it will actually create the project, enable all the APIs that I mentioned, and create the artifact registry and the buckets. All right, so the script's finished. Now you can see here, 2 buckets, like I mentioned, are populated. Again, they're currently empty, and also the artifact registry, also empty. So now need to run second script. So again, as you can imagine, it's a setup LLM script. As I said before, this script is going to download the model weights into the bucket. So, 20 minutes, we downloaded the model weights. We downloaded TGI Docker image and deployed it in the Cloud Run. And TGI, in case you don't know, it's text generation interface created by Hugging Face, and they handle efficient tokenization and continuous batching, so you don't have to write that code yourself. So we have TGI, model weights, and the first Cloud Run service. So now we run the final command to deploy the rest of the Cloud Runs. So again, this will take some time. This script will also automatically launch Cloud Composer. So this will also take about 10-20 minutes. Okay, all the services deployed. Cloud Composer finished deploying as well. There was no need to upload the DAG manually or any other manual steps. The script did it. The script did all of it. Here you can see all the Cloud Run services. So even though we're in the backend, we can still trigger the DAG manually. It just won't connect to the front end. So we'll do that here, and you'll be able to see all the steps clearly that happens in the background every time there's a front end request. Okay, so it took some time. It used the default YouTube video. There's you can paste in a YouTube video here, and so it used that for the DAG trigger. And so if you look at you can see the time it took. And to push, once the summaries have been generated and validated, they are placed in the VidSynth results bucket. And this is like a database that the front end queries from. So thank you. That was our presentation.